This screencast shows the hydroboration of an alkene to make an alcohol. The reaction of hydroboration of an alkene is a concerted reaction, which means that all the bond forming and bond breaking happens at the same time. So we don't really have an intermediate, we have a transition state, and this transition state with the boron away from the ethyl group is favored sterically. Because there's also charge separation in this intermediate, this option is also favored electronically compared to the other alternative with the boron attached to the more substituted carbon. Because the reaction happens in a concerted fashion, there's also a syn addition. The hydrogen that adds is cis to the boron that added. So it pushes the ethyl group to the back. Technically, this reaction happens 3 times, so that I have 3 alkyl groups attached to a single boron. I'm just going to write that as 2 R's attached instead of drawing in all 3 of the R's. The next step that happens in this reaction is the trialkyl boron compound reacts with hydrogen peroxide, and the hydrogen, an OH group, replaces the boron on the alkyl group in its exact same stereochemical position. So I have a syn addition. That's stereochemistry. And I have an anti-Markovnikov addition, and that is regiochemistry. I have not shown the mechanism for the oxidation that follows the hydroboration. You're not responsible for knowing that part of the mechanism.